Okay, problem number 16. We have the cosecant of theta, which is 12 over 5. So again, if we make our right triangle, okay, and understand this is theta right here. Now understand that cosecant, remember cosecant is the same as 1 over sine, which is basically going to be hypotenuse over opposite. So if they give us 12 over 5, therefore we know the hypotenuse is 12. We know the hypotenuse is 12. We know that the opposite is 5. And now we can find the missing side by, again, if we call this a, therefore a squared plus 5 squared equals 12 squared. So we have a squared plus 25 equals 144. So a squared is equal to 144 minus 25. So we have a squared equal to 119. So therefore a is equal to the square root of 119. Okay? So here we go. We have sine of theta, which is opposite over hypotenuse, that's 5/12. We have cosine of theta, which is the square root of 119 over 12. We have tangent of theta, which is opposite over adjacent. So that is going to be 5 over the square root of 119, which is the same as 5 square root of 119 over 119. We have cotangent of theta, which is the reciprocal of tangent. So that's the square root of 119 over 5. We have the secant of theta, which is the reciprocal of cosine. So we have 12 over the square root of 119, which is equal to 12, which is equal to 12 square root of 119 all over 119. And finally we have the cosecant of theta, which is going to be the reciprocal of sine, so that's 12 over 5. Okay? So that takes care of number 16. Going now to 18. Here we have the secant of theta. By the way, secant is 1 over cosine, which is the same as the hypotenuse over the adjacent. So if they give it to us as 17 over 5, Therefore, when we build our triangle, okay, if this is theta, that's theta, then our adjacent is 5, and our hypotenuse is 17. So if we call this b, so we have 5 squared plus b squared equals 17 squared. Okay, so we have 25 plus b squared equals 289, and therefore b squared is equal to 289 minus 25. So b squared is equal to 264. Or b is equal to the square root of 264. Can we simplify that? Let's see. So if I have 264 and I look at, divide that by 2, I get 132. If I divide that by 2, I get 60, let's see, what would that be? 50, that would be 66. Okay, and then if I divide that by 2, I get 33, and there's 3, and there's 11. So it looks like that's going to be, there's a pair right here. That's going to be 4, let's see, 33, 66. So square root of 4 times the square root of 66, so that's 2 square root of 66. So b is equal to 2 square root of 66 in reduced form, and away we go. So we have sine, so this is 2 square root of 66. Okay, so the sine of theta, opposite over hypotenuse, so I have 2 square root of 66 over 17. Cosine of theta, which is adjacent over hypotenuse, is 5/17. Tangent of theta, which is opposite over adjacent, so that's 2 square root of 66 over 5. Okay, cotangent of theta is tangent reciprocal, so that's 5 over 2 square root of 66, which is the same as 5 square root of 66 over 2 times 66, which should be 132. Yep. So 5 square root of 66 over 132. Then we have secant of theta, which is going to be 1 over cosine, so that's 17 over 5. And finally I have cosecant of theta, which is the reciprocal of sine, so that's going to be, let's see, that's hypotenuse over opposite, so that's 17 over 2 square root of 66. That's a lousy 17. Okay, so and that can be changed to 17 square root of 66 over 2 times 66, which is 132. Okay.